Okay, we are given this question, a polynomial question, and it says that when f of x, which is equivalent to x cubed plus ax squared plus bx plus c, is divided by x minus 3, the remainder is 30. If x squared minus 4 is a factor of f of x, find the value of a, b, and c. So let's see how we go about solving this polynomial. Now we have been given that when it was divided by x minus 3, the remainder is 30. So we can say that when divided by x minus 3, so we have f3 equals to, so what you do is you substitute 3 into this function. So we have 3 cubed plus a into 3 squared plus b into 2 into 3 plus c equals to, they said the remainder was, let me check the remainder again. They said the remainder is 30. So everything will be equal to 30. So what we now have is 27 plus 9a plus 3b plus c equals to 30. Let's see whether we can see have 9a plus 3b plus c equals to 3. So let's call this I1. I brought this 27. Okay, let's do it like this. 30 minus 27. So that would be equals to 3. So we have this as our first equation. So now when the question says that x squared minus 4 is a factor, we said x squared minus 4 is a factor of f of x. That means there was no remainder when x squared minus 4 was used to divide this f of x. So what it means is that x squared minus 4 is equivalent to x minus 2 and x plus 2. It implies that x minus 2 and x plus 2 are factors of f of x. That means there won't be any remainder if we use x minus 2 and x plus 2. So when this original function we are given, minus 4, let's say is equals to h of x without any remainder. So our remainder in this case is 0. So what it means is this. I'm trying my best so that you understand what I'm trying to do. What it means is this. X minus 2 and x plus 2. It will still give us h of x. So it means that x minus 2 is a factor of this function, and x plus 2 is a factor of this function. So when x plus 2 is used to divide f of x, the remainder is 0. So we have f minus 2, because we are using x plus 2 to divide, so the remainder will be, so we now have minus 2 all cubed plus a minus 2 all squared plus b into minus 2 plus c. Everything will be equals to 0. So we have minus 8 plus 4a minus 2b plus c equals to 0. So what we have here, 4a minus 2b plus c is equals to 8. So let's term this. Let's term this 2. Now we move forward. When we now use our, we used so when x minus 2 is also used to divide f of x, the remainder is also 0. So we will now have f2 that will be equals to 2 cubed plus a into 2 all squared plus b into 2 plus c equals to 0. So what we have there will be 8 plus 4a plus 2b plus c equals to 0. So we can rearrange this and say is equals to minus 8. So we have this, we have gotten 3 equations, 3 systems of equations. So we will go about solving that right now. So I need to bring out all the equations for us to see, so it will be easier for us to tackle. The third one, I have this. So I'm going to copy it here. The second one is this. I'm going to copy it also and put it here. And the third one, that's equation 1, which is the first one we got. We are going to put it here also. It's this man. So I'm going to copy it also and put everything so that it will be more visible for us to see. So now we have these 3 equations. So we have brought out the 3 equations. We can see them. Now let's quickly solve this. If we solve this, now subtract equation 3 from 2. So we are subtracting equation 3 from 2. So let's see how we go about that. If you are subtracting that, what you have, this man 4a minus 4a will go to 0. This one we are subtracting it, so it will be minus 4a. So we are subtracting this. This one will go to 0. This will turn to 16. So we are equals to 16. That minus will change to plus. So our b, this will be b. Sorry, this will be b, not a. So our b is equals to minus 4. So we've gotten our B. Now the next one, subtract can pick any of, let's say we are subtracting 2 from 1. Sorry about that. So subtract 2 from 1, so it's easier to subtract. So 9 minus 4, that will give us 5a. 3 minus, that will be 5b, plus 5b, that will go equals to minus 5. So we have that. So we know the value for our b. Our b is minus 4. Our b is minus 4. So let's put that. So we have 5a plus 5 into b minus 4 is equals to minus 5. So we have 5a minus 20 is equals to minus 5. So 5a is equals to 15. So our a is equals to 3. So we have gotten the value for a. So substitute a equals to 3, b equals to minus 4, into equation 1, or anyone. You can pick any one. So let's imagine that we are picking it and we are putting it into equation 1. So our equation 1 is this. I'm going to copy it out so that we can get the value for our c. So 9 into 3 plus 3 into minus 4 plus c is equals to 3. So we are going to do that now. So we have 27 minus 12 plus 6 is 27 plus c is equals to 3. So this will give us 15 plus c is equals to 3. So our c is equals to minus 12. So we've gotten the value of our c. So we can bring out, we can now write the polynomial we are given originally is this polynomial. So I'm going to copy it out. Our f of x is our f of x. So my f of x now is equals to x cubed plus our a. We've gotten our a to be 3. That will be 3x squared. Our b is minus 4x plus our c is minus 12. So this is the polynomial that we are looking for. So you can test, you can do a test by substituting any of the values in. You can substitute, let's say we substitute 2 into it. Let's test with 2. Let's imagine that it's 2, and that the remainder at that time should be 0. So let's imagine that it's 2. That would be 2 cubed plus 3 into 2 all squared minus 4 into 2 minus 12. So let's see what that gives us. This is 8. That's 4. 4, that's plus 12. That's 12 minus 8 minus 12. Everything will be equals to 0.